Hello everyone. On this good day, we are going to discuss worksheet questions based on communication systems. Let's enjoy. Yes, learning physics is a joyful thing, right? We'll enter into carrier wave peak voltage. Let me change another color. Carrier wave peak voltage. Carrier. So AC is equal to 10 volt. Used to transmit a signal. What would be the peak voltage of the modulating signal? In order to have modulation index is 80%. Okay, carrier wave 10 volts and modulating peak voltage of the modulating signal AM not mu m, AM is equal to how much? Mu is equal to AM by AC into 100. So 80 is equal to AM by AC is 10 into 100. So 0 0 cut, 0 0 cut. So AM is equal to 8 volts. So this is modulation index related question and this is the formula for it. Next, the range of frequency bands used for standard AM broadcast. These type of things should be memorized from the tables. Okay, no shortcuts like things. You have to memorize the table. At least a few you have to memorize. Next, a TV transmission antenna is 40 meter tall. H is equal to 40 meter. How much service area can cover if the receiving antenna is at the ground level? So earth radius is given. So distance coverage is equal to square root of like 2GH, here 2RH is the distance covered in horizon. So this will be the distance. He is asking how much area can be under coverage. So area is equal to pi d square, whatever this. Okay, pi d square. D means D stands for distance, not for diameter or something else. So 2RH. So nothing but 2 pi RH. Substitute 2 into, answer is in pi's only. So have a look on the options. Options are in pi only. Don't waste your time and don't waste in taking square root also. And R value 6400 kilometers into 10 power 3. H is equal to 40 meter. So that is equal to I have y12 pi into 10 to the power of 6 meter square. SARs have advantage, right? Next, for an amplitude modulated wave, the maximum amplitude is found to be 10 volts. A maximum is equal to 10 volts. And while the minimum amplitude is found to be A minimum is equal to 4 volts. The modulation index is equal to MIAV is equal to A max plus A min by A max minus A min, isn't it? Then what will come? 14 by 6. That means 2 table will go 7 by 3. So 7 by 3, here it is in reverse. Modulation index should be always less than 1. That means I wrote in reverse. Yeah, this is minus and this is plus. Modulation index must be less than 1 always. So this is minus, this is plus. So 14 here, 6 here. So that will be 3 by 7. The option. A message signal is superimposed with a carrier signal. The resulting modulating signal CN, okay, omega and omega to omega 3, okay, fine. Index, then angular frequency of the message signal respectively. Angular frequency of the message signal. After superimposition, he may be asking omega 3 minus omega 2 by 2. Omega 3 minus omega 2 by 2 is message angular frequency. So obviously answer must be D. Here it is omega 3 minus omega 2. Yes. Carrier signal frequency V1, peak voltage of V1 is modulated by a message signal of frequency nu2. Maybe these are nu1 and V1. This is nu2 and V2. Let M be the modulation index. Sidebands produce which of the correct statement? Okay, Sidebands produce it, of course, but modulation index he is using, he is asking. Okay, both are there. The sidebands frequencies are there as well as modulation index also there. Modulation index M is equal to AM by AC. Yes, AM by AC. So what is AM? A carrier signal of voltage, carrier will be V1 and this is V2. So V2 by V1 and M always less than 1, isn't it? M always less than 1. Why did he give V2 by V1 M greater than? Let me check. Oh, any one option only we have to select. Okay. And modulation. V plus sideband and V minus sideband produced, which is the correct statement. Okay. V1 is equal to V plus plus V minus by 2. Not like that. V plus will give you Vm plus Vc, carrier plus message, and V minus is equal to V carrier minus Vm. So if you add these two, then Vc by 2 will come. That means mean to say carrier frequency will come. Carrier frequency is here nu 1. So nu 1 is equal to nu plus plus nu minus by 2. So carrier 1 will come. That means B option is correct. Yes. Encourage yourself. Okay, next. A message signal is used to modulate a carrier frequency. Message signal used to modulate a carrier frequency. If the peak voltage of the message signal and carrier signal are increased by peak voltage of message and carrier are increased by peak voltage of message, that means AM is increased by 0.1% and carrier AC is increased by 0.3%, then the percentage change in modulation index. Wow. Mu is equal to or M is equal to AM by AC is our formula, right? Percentage change in MIAV is equal to percentage change in AM plus percentage change in both are increased. Whenever he gave increased, then you can use the signs. If he didn't give increase, only change, then only plus you have to take. And percentage change in AC. Percentage change in AM is 0.1% minus this is 0.3%. That means you are going to have 0.2% with a downward trend. So minus 0.2%. B. Next. Yes. An antenna is mounted on a tall building. H is equal to 400 meters. What will be the wavelength of the signal? Signal that can be radiated effectively by the transmission tower if the range is R, range means D. D is equal to 44 kilometers. What will be the wavelength of the signal? What is the wavelength of the signal of that can be radiated effectively by the transmission tower up to a range of 44 kilometers? We have H is equal to lambda by 4. That aspect we can think. If any other possibility for anything? Yes, here we have H D. D is equal to square root of 2RH. So D square by 2R is equal to H. D square by 2R is equal to H. So effective height we have to find out. Maybe symbols are confusing to you. Let me change up. Symbols may confuse you. So this is R value and this I can call as D, so that 400 into 400 by 2 into 44 into 10 power 3. So this is equal to roughly 151 kilometers, 151 meters only. So this is, we have H, and H is equal to lambda by 4, lambda equal to 151 into 4. So around 604 meters. So this is nothing but option B. The amplitude of sidebands of the modulated signal of the carrier signal and message signal amplitudes are 25 volt and 5 volt respectively. Modulated signal of carrier signal and message signal amplitudes. Carrier always larger and message usually smaller, 5 volt respectively. Then amplitudes of the sidebands. Sideband modulated amplitudes. Then sideband amplitudes are mu AC by 2. Mu is modulation index. What is modulation index? Modulation index is equal to AM by AC into AC by 2. So AC gets cancelled, AM by 2 will come. AM by 2. AM by 2 means AM by 2, that is 5 by 2. 5 by 2 is equal to 2.5. The frequency is suitable beyond horizontal communication of skywave, memorizable things. And then the maximum number of TV signals that can be transmitted along coaxial cable, 100. Memorizable thing, 125. Okay. A base band signal of 3.5 megahertz frequency 3.5 megahertz modulated to a carrier of FC is equal to 3.5 megahertz. Even this is also 3.5 only. Okay. In amplitude modulation method, what should be the minimum size of the antenna required to transmit the modulated signal? Minimum size of the antenna. Okay. Can use C is equal to 3 into 10 power 8. And from this lambda can come. With this H is equal to lambda by 4 you can. Will be better. So here lambda is equal to C by nu or F, whatever. C is 3 into 10 to the power of 8 by nu is equal to 3.5 into 10 to the power of 6. So megahertz, right? So it will be 300 by 6 will go now, that's why 3.5 I took. So it is 3000 by 35. 3000 by 35 and H is equal to lambda by 4. Lambda value 3000 megahertz and meters per second, yes, and 35. So implies it is equal to implies H by 4 we want, right? 35 into by 4 kada. So by 4 will be 1500. By 2 only 1500. So another 2 will be 750. 750 by 35. 750 by 35. 35 twos. Yes, 2 will come. So units are not exactly matching. Is it kilohertz or megahertz? Let me check. It's not here. mm meters we are getting 35 2 times 2 1 2 35 twos are, and after 70 50 came 1, so 21 point something meters only coming, not mm. 21 meters is coming. This is not C option, it is D option. It is D option. Meters only coming, not millimeters. Anyway, you check yourself once. I got like this. 3 amplifiers with voltage gains. Amplifications are in voltage 10, 20, 30. If the input signal V in is equal to 1 millivolt, then V out is equal to how much? Net amplification is equal to 10 into 20 into 30 is equal to V out by V in, right? So V out is equal to 600 into V in is 1 millivolt. So 600 into 10 to the power of minus 3 volt. So it is 6 volts. Option A. The signal of frequency 10 kilohertz and peak voltage 10 volt. Signal of frequency 10 kilohertz. Signal of frequency 10 kilohertz. F message is equal to 10 kilohertz. And peak voltage AV is equal to, or A signal only no, so AM is equal to 10 volts. Use it to modulate amplitude wise. The carrier frequency FC is equal to 1 megahertz. And the peak voltage is A of carrier 20 volts. Okay, sideband frequency in kilohertz is sideband frequency mu into AC by 2, isn't it? Why this one? This is sideband frequencies, or you can add and subtract, right? FM plus FC is equal to 10 kilohertz. 10 kilohertz. This is 10 kilohertz plus 10 to the power of 3 kilohertz. So 10 plus 10 power, that means 110. This is 101. Yeah, 1000 plus 10, right? 1000 plus 10, 1010, 1010, correct only. Kilohertz, and FC minus FM is equal to 1000 minus 10, 990, yeah? 990 kilohertz. So 990 and 1010. Okay. A transmitting antenna of height 105 is placed on a hill. Transmitting antenna height h is equal to 105 meter is placed on a hill. Transmitting antenna height 105 meter and placed on a hill. Then coverage area is, okay, area is equal to pi into whatever the distance, that's square. So pi into 2RH. So 2 pi and 6400 kilometers into 100 by this one also I want to write kilometers only. That means 10 to the power of minus 3. Okay. So 2 zeros will go, 1010 will go. Pi value 3.14, and after simplification 3 2s are 6, 6 are 36. So it's on multiplying 3.14 completely, we'll have option A, 4224 kilometers square. Just simplify it. Antenna uses electromagnetic waves of frequency f is equal to 5 megahertz for proper working. For proper working, the size of antenna should be, an antenna uses electromagnetic wave of frequency 5 megahertz. For proper working, the size of antenna should be, antenna uses electromagnetic wave of frequency 5 megahertz. Size is equal to C equal to 3 into 10 to the power of 8, and lambda is equal to C by F, that is 3 into 10 to the power of 8 by 5 megahertz 10 to the power of 6. So it will be 3 by 5 into 100. So 5 will go 20 times, 60, and this will be 320s are 60. What is this? Wavelength, meters. Now h height equal to lambda by 4, 60 by 4, 15 meters. Basic communication system consists of transmitter, information source, user information, channel, receiver. The correct things are correct things in order also. Okay, first one, channel, user information, information source, transmitter. So order you need to follow. Okay, they are information source, next transmitter, next channel, next receiver, next user information C. So BADC, oh chalo, B. The waves used for line of sight communication, sky wave propagation, sky waves, space waves, space waves, yes, line of propagation, space waves only, right? Yes. Sky wave propagation, reflection from ionosphere layers. Ground wave is microwaves, right? Modulating signal is a square wave as shown in the figure. Okay. The carrier wave signal is this one. What is that? The modulation index is equal to, okay, its amplitude is how much? Amplitude of carrier is equal to 1 milli, what is MT? Millivolts maybe. Okay, that we'll discuss. And here it is 2 volts. Yes. No, carrier is 2 from this. Okay, and message is equal to 1. So AM by AC is equal to mu, that is 1 by 2. Message signal of frequency 5 kilohertz. message signal of frequency 5 kilohertz and is used to modulate a carrier signal of frequency 2 megahertz. Carrier signal of frequency 2 megahertz. 2 megahertz. And bandwidth for amplitude modulation. Bandwidth for amplitude modulation is yes, bandwidth is 2 times of frequency of message, 2 into 5 into 10 power 3, that is 10 kilohertz. The height of transmitting and receiving antennas are 80 each. H1 is equal to H2 equal to 80. The maximum line of side distance for the given. D1 plus D2 is equal to root over 2R H1 plus root over 2R H2. That is nothing but 2 times of root over 2R H1. That is 2 into root over 2, R value 6400 kilometers into 10 power 3 into H1 is 80. So this is 2 80s are 160. 160, 2 into root over 160 into 64 into 10 to the power of 5. This 0 will give you 10 power 6. So 2 into 4 into 8 into 10 to the power of 3. So it's in kilometer. 288 64 kilometers. So option 4. Sinusoidal carrier voltage is amplitude modulated. The resultant amplitude modulated wave has maximum and minimum amplitude of 120 volt and 80 volt. So come again, AC plus AM is equal to 120 volt and AC minus AM is equal to 80 volt. On adding 2AC equal to 200, AC equal to 100, okay, and on subtracting 2am is equal to 2m equal to 40, so am is equal to 20, adding and subtracting, okay. Then modulation index is equal to am by AC. Modulation index is equal to am by AC, that is equal to 1 by 5, and sideband amplitude is equal to mu into AC by 2, right? Mu value 1 by 5 and to AC is 100 and by 2, so 50 by 5 will go 20, 20 by 2 is 10, so 10 volt should come. Amplitude of 15 sine this and is modulated by 10 sine this signal. The amplitude modulated signal contains frequency of amplitude modulated one contains frequencies of 15. The one is 1000 pi t. 1000 pi is equal to 2 pi. If 2 pi f, pi gets cancelled, f is equal to 500. And the other one is 4 pi. 4 pi is equal to 2 pi f. 2 if I write pi gets cancelled, f is equal to 2. This is message signal and this is carrier signal. Okay. So in between 502 and 498. In between 502 and 498, which will come? Okay. B only, A and B only, ADE only. In between 502 and 498. So which will come into it? They are only the answers. So option C, ADE. ADE, yes, correct. Modulation index. For an amplitude modulated wave, minimum amplitude AC minus AM is equal to 3. Okay, and mu is equal to, we have AM by AC. Mu modulation index equal to 60%. 60%, that means 0.6. That means AM is equal to 0.6 AC. So we can use in this AC minus 0.6 AC equal to 3. That means AC is equal to 1.0.6 equal to 3. So AC equal to 3 by 0.4, that is 30 by 4. 30 by 4, 7.5, 15 by 2, 7.5. AC is 7.5. That means AM is equal to 0.6 into AC. That is equal to 0.6 into 7.5. That is equal to AM. Okay, after that he is asking maximum. So this is 45. That means 4.5. So now maximum is equal to AC plus AM. AC plus AM means 7.5 plus 4.5. So here 12 it is, 12 volts. Yes. Good question. What percentage of transmission range of TV tower be affected when the height of the tower is increased by 21%? Height of the tower increased by h increased by 21%. Then range increases. Range equal to 2 square root of range is equal to 2RH, right? So you shouldn't multiply with power. You have to go for another technique called 10 into root over 100 plus percentage minus 10. Whenever root is there, then this one you need to use. 10 into root over 121 minus 10, 11 minus 10. So total 10% will come for it. A TV transmitting antenna height h is equal to 98 meters and receiving antenna at the ground level. If the radius of the earth, I know surface area covered area is equal to surface area 2 pi RH, 2 pi 6400 kilometers it is. So into h is 98 by 1000. So automatically kilometer square will come. You can simplify. Carrier wave amplitude AC is equal to 15 modulated by sinusoidal band of amplitude AM is equal to 3. The ratio of maximum amplitude to minimum amplitude is of an amplitude. AC plus AM by AC minus AM is equal to, this is 18 by maximum by minimum. Yeah, it is 12. 6 table will go 3 times, 6 table will go 2 times. So 3 by 2. Next, the transmitting antenna is kept on the surface of the earth. The minimum height of the receiving antenna required to receive the signal in line of sight is 4 kilometer distance. Distance equal to 4 kilometers. Okay, is x into 10 to the power of minus 2. The minimum height of receiving antenna required to receive the signal in line of sight at 4 kilometers distance from it is x into 10 to the power of minus 2. Then find the value of x. Okay, this is again 4 kilometers, right? H is equal to lambda by 4. We need to find out lambda. Lambda can be obtained by finding the frequency and the distances, blah blah blah. Same story whatever we did in the earlier. Okay, simply we will do it's like this. D is equal to square root of 2RH, and for 4 kilometers, 4 kilometers into 4 by 2 into R, 6400 kilometers. Both are in kilometers only. Then H will come in kilometers, but he gave H in meters. So we have to multiply with 10 power 3. Here 10 power 3, one correction is enough. The second one need not. Or if you are scared of, you can do completely. So H is equal to 4 4s are 16. So it will come as, you can simplify. Well, 1.25. Next. And the given below is a conceptual question. Okay. The question is given below. Assertion: EM waves used for optical communication longer wavelength than that of the microwave employed in radar technology. Optical communication. Okay, infrared EM waves are more energetic. Infrared are more energetic than microwaves. Correct only. If the light given statements. Okay, fine. EM waves optical communication have longer wavelength than that of microwaves used in. No. First, so A option. Push yourself to be great and keep on practicing, and that reflects in your result, right? Bye. All the best.